Here's a short video finishing up our lesson on complex numbers. Just a quick review. Remember, when we see the square root of -1, that's I. And if we see I squared, we know that's -1. And I to the third, we showed in class, was -I. And I to the fourth, well, that's just this thing squared, must be 1. Don't forget to simplify your expressions when you multiply and when you rationalize denominators or make common denominators. That's a little glary. That's better. Okay, just a quick review of multiplying with complex numbers. So 2, 3 plus 4i is going to, when I distribute, give me 6 plus 8i. And if I have 2i times 3 plus 4i, it's a little more complicated, but not much more. Here, we'll do it in two colors. We've got the 2i times 3. 2 times 3 makes 6i, right? There's no i's here to do anything with that, so it's just 2 times 3. But then we're going to have, after the plus sign, we're going to have 2i times 4i. And I know that 2 times 4 is 8. And I know that I times I is I squared. But we were just reminded a minute ago that I squared is the same as -1. And so this is going to be 8 times -1. And so I have -8 plus 6i. Okay. And then we also talked about foiling. 3 plus 2i, 5 minus 3i. And how we would do 15 minus 9i plus 10i. And this last one, 2 times -3 is -6, and I times I is I squared. So there's some simplifying we need to do now. Certainly we can combine these like terms, -9i plus 10i, to get 1i. But remember also that I squared is -1. -1 times -6 will make +6. +6 plus 15 is 21. So we get 21 plus I. Okay. And then, don't forget, you should be able to do something like 4 minus 3i squared. Now, we know that's not the same as 4 squared plus -3i squared. Those are not equal. This is a foiling problem. This is 4 minus 3i times 4 minus 3i. And so when we FOIL, we get 16 minus 12i minus 12i. And then -3i times -3i. Well, -3 times -3 is +9. And I times I is I squared. So when I combine like terms, I see here I'm going to have -24i. But what about here and here? Well, this is I squared, so that's -1 times 9. -1 times 9 is -9. So I have 16 minus 9 to combine. So I'm going to have 7 minus 24, 24i. Okay, so there's multiplication with complex numbers. Let's go and take a look at division with complex numbers. So in our normal division problem, we're going to see something like 2 plus 3i, 4 minus 5i. One complex number divided by another. Well, there's nothing really here to do except we see here there's an I, so there's a square root in the denominator. And so we're still waiting for enough of those slide rule people to die. As a result, we have to rationalize this. And remember, we rationalize with the complex conjugate. The complex conjugate does not mean change both signs. We're trying to build something that looks like a difference of squares. So I'm still going to have the 4, I'm still going to have the 5i, but if this is a minus, this one needs to be a plus. So there's my complex conjugate. But if I had 3 plus 2i, then my complex conjugate would be 3 minus 2i, because I'm trying to build that thing that looks like a difference of squares. Why am I trying to build a thing that looks like difference of squares? Because with a difference of squares, the middle terms go away. And so this plus 6i and this minus 6i are going to cancel each other. And so I'm not going to have i's on the bottom anymore, because over here we'll have minus 4i squared, which is the same as plus 4. So that's another thing I guess I should be aware of when I do multiply by the complex conjugate, in this case 4 plus 5i. Instead of getting an a plus bi complex number in the denominator, I'm just going to get a real number in the denominator. 4 plus 5i. Okay, so really all we have to do is some foiling. We'll FOIL on top, 8 plus 12i plus 10i plus 15i squared. And on the bottom, 16 minus 20i plus 20i minus 25i squared. Okay, what happens? I squared is negative 1. 15 times negative 1 is negative 15, plus 8 is negative 7. And then we've got plus 22i over, well here, these terms cancel. I squared is negative 1. Negative 1 times negative 25 is positive 25, plus 16. 16 plus 25 is 41. And so that is the result of my division. It's really just rationalizing the denominator. Okay? Let's do one more of those. And then there's one other problem we need to look at. So if I have 5 plus 4i, 3 minus I. Well, my complex conjugate here, because I see 3 minus I, would be 3 plus I. And I need to multiply top and bottom by that. So on top, when I FOIL, I get 15 plus 12i plus 5i plus 4i squared. And on the bottom, when I FOIL, I get 9 minus 3i plus 3i minus I squared. Okay, so I squared is negative 1. Negative 1 times 4 is negative 4. Negative 4 plus 15 is 11. And then 12i plus 5i is 17i. And then here on the bottom, the middle terms should always cancel. I squared is negative 1. There's already a negative here. So negative times negative 1 is positive 1. 1 plus 9 is 10. Okay? Hey, and remember, as far as simplifying these expressions, if we had 12 plus 18i over 10, we could divide everything by 2. We could factor that 2 out of the top, 6 plus 9i, and a 2 out of the bottom, and cancel those 2's and be left with 6 plus 9i over 5. And that would certainly be the answer I would have on multiple choice. But if you have 12 plus 17i over 10, don't do that. That's pool noodle. That's definitely pool noodle. Now what you could do, 12 plus 17i over 10, you could split this into two fractions like we did in the Algebra Basics unit, and then you could simplify this one to be 6 over 5. But that 17 has to be over 10, because that 17 isn't evenly divisible by 2. And therefore, if you cancel and turn this into a 5, now you have 17 over 5. So pool noodle here, you can only simplify if you can take that GCF out of all three. Okay? Oh, why did it get so dark? Oh, it was my screen dimming for brightness. Silly me. All right, last problem. Let's take a look. It's what happens when you add fractions, essentially. It's 2 plus 3i over 5 plus 2i plus 2 plus 3i over 3 minus 2i. Look, a fraction plus a fraction. So there are two ways you can do this. One is you could rationalize here, and then you'd get one real number. And you could rationalize here with its complex conjugate, and you get one real number. And then you'd make a common denominator. So one approach is to rationalize each separately, then make a common denominator with real numbers. I don't particularly like that method, but you can do it. It will always work. 2, the one I prefer, is make a common denominator at the start. Then rationalize if necessary. And maybe we should try both of these methods. Okay. I got 2 boards. We got 2 methods. All right. So let's see which one we like better. I'm going to start by rationalizing each separately, then making a common denominator. Normally I prefer this method, especially when these are conjugates. Often when we see these problems, we're going to see these denominators as conjugates. So if these are conjugates, I'm definitely using this approach. But these aren't conjugates. 5 plus 2i is not the conjugate of 3 minus 2i. So I think I'm going to see what happens when I rationalize each separately. Okay, so here I need to multiply by 5 minus 2i, 5 minus 2i, and don't forget to FOIL. So we've got 10 minus 4i plus 15i minus 6i squared over 25 minus 10i plus 10i minus 4i squared. But wait, we have to do that over here as well. The complex conjugate here is 3 plus 2i, 3 plus 2i. So when I distribute, when I FOIL, I get 6 plus 9i plus 4i plus 9i squared over 9 minus 6i plus 6i minus 4i squared. Okay, so let's tidy things up. There's negative 1 times negative 6 is positive 6, plus 10 is 16, and here I have 11i. And then on the bottom, these cancel. I squared is negative 1 times negative 4 is positive 4, plus 25 is 29. Plus, and over here, I squared is negative 1, so I've got negative 9, plus 6 is negative 3, and then 9i plus 4i is 13i. All over, these cancel. I squared is negative 1. Negative 1 times negative 4 is positive 4. 4 plus 9 is 13. So this is the place where now we need to make a common denominator with real numbers. See, these are real numbers. So this one's going to need a 29, and this one's going to need a, oops, no, just the opposite, Mr. Kukla. This one's going to need a 13 over 13, and this one's going to need a 29 over 29. So I've got 13 times 16, which at this hour in the morning is not coming quickly to my brain. 13 times 16, 208 plus 13 times 11, 143. 13 times 11, 143. I plus 29 times negative 3 is 87, but don't lose that negative, so we're subtracting 87. And then 29 times 13 gives me 377i, all over the common denominator of 13 times 29. So let's tidy this up. 208 minus 87 gives me 121. And then 143 plus 377 gives me 520. Don't lose the I. And 13 times 29 is 377. Okay, so there's my answer, and that's my answer by rationalizing and then making a common denominator. But we could try making a common denominator first and then rationalizing if necessary. And I bet it will be necessary in this case because these original denominators are not complex conjugates. So let's start with this problem again. We've got 2 plus 3i, 5 plus 2i, plus 2 plus 3i, 3 minus 2i. All right, so this time I'm going to make a common denominator. So this one needs a 3 minus 2i, 3 minus 2i, and this one needs a 5 plus 2i, 5 plus 2i. And again, I FOIL. Lots of foiling here. I'm so glad we're comfortable with foiling for these problems. So we've got 6 minus 4i plus 9i minus 6i squared over 15 minus 10i minus 10i plus 6i minus 4i squared plus 10 plus 15i plus 4i plus 6i squared over 15 minus 10i plus 6i minus 4i squared. All right, let's tidy up. The denominators are the same, so I know where I'm going with that. That's negative 1 times negative 4. 4 plus 15 is 19, so my denominator is 19. Is it the same? Oh yeah, because I made a common denominator. Okay, and then up top, what do I have? Well, I squared is negative 1. Negative 1 times 6 is 6. 6 plus 6 is 12. And then here, minus 4i plus 9i is 5i. Now over here, we've got 15i. We've got negative 6 plus 10 is positive 4. So I end up with 16. Is that 59? No, that's 99. I end up with 16 plus 24i over 19. Oh, I like that. Look, we're done. So I really prefer the make a common denominator approach. Make a common denominator when you do a problem like this. And that's it. You should be able to get through the rest of the homework. I know there are a couple of quadratic formula problems, but you should remember that x equals negative b plus and minus square root b squared minus 4ac all over 2a. Have a wonderful day, everyone.